So welcome everybody. My name is Mr. Taylor, and we're going to be talking about sixth grade data from using STAR data and using the information that we had from last year. I would like for everybody here to introduce themselves. This is a team at Spring Forest Middle School, the sixth grade math team.
Mr. Leon.
Mr. Leon.
Miss Lee.
Miss Lee.
Mrs. Giano.
Miss Jean.
Okay, so and as you can see, she's here, so you can see that there's a person there. They're there. Okay.
Okay.
And then we have Miss
Hi, Miss Smith.
Miss Smith. Okay. Oh yeah, you're good. All right. So we're going to be talking about the sixth grade data, using data to drive our instruction, and we're going to move on. Nice. If this was in there, huh?
Let's start again. We all are prepared. We are here, ready to go. All right,
Yeah.
let's start again.
Okay, let's start. Okay, so we already made introductions. I'm Mr. Taylor at Spring Forest Middle School. We're going to talk about sixth grade math and using this PLC meeting to kind of look at certain things that we see being a trend in terms of the areas that students here, sixth grade students here, are struggling with. Based upon the data. These are the data sources that we use: STAR data, performance data, item analysis, and standards. And the purpose of this is to identify the clearest academic concern and plan targeted next steps. So we're going to use the data to drive those decisions. Okay. All right. So the longitudinal data, that fancy word, basically means that it's hear the word longitudinal. It means that over a 3-year span. So it's not just data we compile for 1 year and say, hey, this is a problem. It has to be something that's continuous, that shows a trend, and it did. It says a persistent low performance in TEAC 6.8A and persistent low performance on TEAC 6.8D. Can somebody tell me what those TEACs are?
So 8A is extend previous knowledge of triangles and their properties to include the sum of angles of a triangle, the relationship between the lengths of sides and measures of angles in a triangle, and determining when 3 lengths form a triangle. So there are 3 things in one supporting TEACs.
Okay.
And the next one is 6.8D, determine solutions for problems involving the area of rectangles, parallelograms, trapezoids, and triangles, and volume of right rectangular prisms where dimensions are positive rational numbers.
Right. And you mentioned some, so which one, you said one of them was a supporting standard and one was a standard. How did you break that down?
So based on what we get, like 8A is the supporting standard, so it means that we can have 1 or no questions about it.
Okay.
8D is the readiness standards, and we might have 2 or more questions about it.
Okay, good. All right, so the concern is concentrated in geometry and measurement. And those are some conceptual things. And focus on me here. Okay. All right. So the identified academic problem is that grade 6 students are struggling to master geometry and measurement concepts. And can you guys read some of the things that it impacts?
It limits mathematical reasoning.
Impacts grade level tasks and creates conceptual gaps.
Yeah, so an instructional challenge, address the gaps while continuing to teach the required grade level curriculum. So we know you guys are on the curriculum here today. You guys are talking about dividing and fractions and things like that, evaluating fractions and those concepts. But you can still, when you're pushing students to get to that higher order or higher level of cognitive reasoning to increase their level of rigor, it helps them when they start to be better at explaining things. And even though it's not dealing with geometry right now, because you guys are doing fractions, but getting them to the idea of thinking about why is this answer the right way, getting them to that point of explaining their answers, that can help them when they get to areas like this. Okay, so so instructional impact. Teachers may need to spend additional time on these 3 things. What are those 3 things?
Revisiting prerequisite concepts, clarifying mathematical vocabulary, and connecting formulas to visual representations.
Yeah. Okay, so that's why I'm big on the vocab, and using that language consistently will help them, because that's the language they're going to see on the exam. So goal of instruction is to help students access new geometry and measurement content with stronger conceptual understanding. It's all about that conceptual understanding, because that's the area that shows concern. So here's the graph of the data, and in 2023, as you can see, 6.8A improved in 2025. So we did see some improvements, but but overall it's still below 40. It was just it's the lowest, so that's why I picked that one. And while 6.8D continued to decline, and as you can see, the 6.8D is this one in this color. So it starts off high, then went to 30, then went to 24. So that's a big thing, and that's you call that, what standard did you call that?
So it's the readiness standard, and also it has area of rectangles, parallelograms,
Yes.
trapezoids, triangles, and volume of right rectangular prisms.
Yeah.
So there are 6 concepts in
Six
it.
concepts in there. So yes, you guys can see there, and addressing the academic concerns. So anticipated student outcomes. Who can read that for me?
Conceptual understanding, accuracy with math reasoning, and geometry and measurement tasks.
So that's what we want them to be able to demonstrate. So the next PLC move is to select the highest leverage instructional response that aligns to these two things. And even though you guys aren't there yet, just start to think, even when you guys get closer to these T's, start to think of ways where you can kind of start front loading to them those ideas, so when they get there, they're not overwhelmed, because it's a 3-year trend that shows it's an area of struggle. So we don't want it to be a 4th year where they're struggling. Let's see if we can make those numbers.
So we could actually do that now with the decimals. We
Oh,
throw in a couple problems because we're doing decimals, right? Decimal,
Yeah.
multiplication, division, addition, subtraction.
Mhm.
So we could create some area problems.
Yeah.
Yes, and it
or
says
perimeter
that
problems, yeah.
where dimensions are positive, it has to be positive, but rational numbers. So we can start, at least we can meet where they are.
Mhm.
Like they know rectangles
Mhm.
and they know parallelograms, and we can start at least like focusing on those 2 shapes.
Yeah.
Then when the time comes, we can focus on trapezoids and triangles in the
Mhm.
volume.
Right. So sort of like getting them prepared before they get there,
Mhm.
so they already have some sort of background knowledge about it. And so, what are some, like she said, in using like decimals and fractions and things like that? What are some conceptual gaps that can be used to help them before they get to that point?
I think understanding why formulas work,
Mm-hmm. Uh-huh.
like, and also cannot explain what dividing by fraction means.
Right, yeah.
Yeah.
Yeah, those are just some things that if they can't explain that, and those are ways that you can help them. Like I said earlier, if you're helping them through those challenges they're having with the fractions and things like that, it's still, even though it's not directly tied to shapes, it's still helping them with the concept and getting them on that level of thinking, a higher level of rigor in terms of the cognitive demand. What else? What are other conceptual gaps that you guys see that you guys can use even in working with fractions and things like that you can use to help them with these things?
Not recognizing like equivalent fractions,
Okay.
so helping them like understand how to simplify, and then even I think just like going back to the basics of like understanding math facts.
Yes.
So being able to get like the inverse relationship between multiplication and division.
Good. See, yeah, those are concepts. Yes.
Yeah.
Yeah.
Understanding that fraction is also like a form of division, so recognizing that
Mhm.
when you're dividing, like that fraction bar also represents a division sign.
Wow. Yes. Yeah.
And then just basic arithmetic mistakes, right?
Yeah.
Just understanding how to set the problems up and
Yeah.
procedural errors. So
Mhm. All right. Good. Good. Right. So that's all I have for you guys today. Do you guys have any questions?
Are you still doing the behavior?
Yes, I am.
Have you got one for you?
Yeah.
No, you gotta make your 2 by 2.
That was really eye-opening though, like,
Right.
because this is our unit 10,
Mhm.
and currently I'm working on this, the unit 10.
Unit 10, yeah.
And I was like, one of our biggest thing is how we can, like, looking at the, like how the topics, how the lessons
Mhm.
are rolled and how they connect with each other.
Yeah.
So usually we teach when the time comes, but like seeing 3 years trend, and after that, like I saw even this year,
Mhm.
it's continued to be the trend.
Yeah.
And it's very eye-opening for me, like how we can use at the beginning of the school year to support something end of the school year. That's why it was really helpful.
Yeah.
Yeah.
Yeah, bringing those concepts in and tying them in
Yeah,
early.
exactly.
Okay, anybody else have any comments?
I can see us doing more as we get into like the order of operations, into the equations.
Mm-hmm.
Yeah.
See that more?
Yeah.
I mean, I could even see right now doing the rectangle and saying, what happens if we cut it in half? What do you have? Triangle.
Yeah.
Oh, I could
Yeah.
even see doing that.
Oh wow, yeah. Yeah.
Making
To
the
get head start.
connection.
Mm-hmm.
Because there is another text, it says understanding the formulas.
Understand the formula.
So like in here, it's like triangles, finding the area of the triangles, and like, and I looked at that text, like understanding the formulas, and like students were doing well understanding formulas of like why the formula of triangles formed,
Right.
but like then it's so broad.
Yeah.
So like teaching just one text, usually we teach it in like 3-4 days, and like there's no way we can finish everything in 3-4 days. So like how we can combine, how we can compact, how we can support this text in like throughout the school year.
Like strategically, right? Because you don't want to overwhelm them like you're teaching a bunch of texts at once, but it's kind of like just tying in those concepts from 6-8D and 6-8A into what you're doing throughout the year.
And also, like there are so many things we see in 6th grade that we don't see it in 7th grade.
Yeah.
We don't see first part of 8th grade, and the second semester of 8th grade we see those things come in, like the side lengths of triangle.
Yeah.
It really merges with Pythagorean theorem. So like then it's not just in 6th grade how we can do like those spiraling,
Right.
like what we can do for 7th grade for them to keep that
Keep
knowledge and skills to move to 8th grade.
So
It's
like keep
very-
that consistency to
Yeah.
6th, 7th, and 8th.
Yeah.
Was the slideshow showing from 6 to 8, or was it showing from 6 and before?
Oh, good question. It was just showing just 6th grade.
Okay,
Yeah.
just 6.
Just 6th grade. Yeah. And these were and these were
That-
the
that
data.
one. Yeah, right there.
Yeah. 6-8A is in the blue and 6-8D is color, and those are like the lowest. I mean, there were other areas that were low, but those were the
Lowest performing
performance,
standards.
and that was like consistent from year to year.
Well, we know why on the triangles.
Why?
Because that's like the very last thing, and we get like 1.5 days or something to teach it. We run out of time for it. And then I really think for the area and stuff is they don't look at they don't use the correct formula, the dividing by 2 for like the triangles and the trapezoids. That's a big problem too. I don't think it's so much math as it is that.
So that's
Or
good.
like
So you guys are already thinking ahead of
Going
certain
back in here,
certain
I'm so
misconceptions.
sorry.
No, you're good.
Going
Yeah.
back in here, dividing by 2 is like when we multiply base and height, then we have a huge number, then we are forcing them to divide by 2, but it's at the same time multiplying by 1/2. Like as you said, how
They just don't have the
Fraction.
relationship of like understanding even like just terminology. It's
Yes.
so funny because I think part of it is like even in elementary, there are a lot of times we teach things to a certain formula. Like everything is kind of done in a specific way. So for example, when finding like perimeter area,
Yes.
9 times out of 10 they're not given the perimeter or the area, they have to solve for it. So they're so used to just plugging in the formula.
Oh.
Whereas here it's like almost
Working
backwards.
backwards.
They're given the perimeter in the area, so they have to understand now I'm doing the opposite of the formula. So it's like the relationship of like the concept I think is almost not really there because they're so used to the drill and kill of one system.
One system.
So-
Oh, that's tough.
And then on
Wow,
that,
that's
like to
good.
top that off, like elementary, we
Yeah.
never teach them that 1/2 or like the fraction bar is dividing. They're just taught like 1/2 or like divide by 2. Like they're never, we don't really overlap the
Oh, I
worlds.
see what you mean.
But
So-
I do say though, both my academic and my AAC classes today know that fraction bar means to divide.
That's really impressive.
So yeah,
Yeah.
I'm like kind of impressed by it. So I think it's
Yeah.
impressive.
So anticipating those misconceptions are going to be good because, as you said earlier, like you're noticing some of the things that they make mistakes on. So getting out ahead of it
Yeah.
will be very, very good.
yeah, we can support them now.
Mm-hmm.
Versus the end when we're all
Yeah.
overwhelmed, exhausted.
And like when we look at the trend, all those years,
Yeah.
we did not use models. Like,
Oh yeah, it's nothing.
that's
models,
another
right?
thing. We did not
Yeah.
use models, and if we continue to do the same thing, we cannot expect
Set
the
different
different
results.
outcomes. So
Yeah,
then this year we are gonna add models
models.
into it.
Okay.
Models for what?
Models
Alright, so
for
this
the
is going
triangles.
to-
Oh, I do
Models for the no, like they connect. You know that.
To the formula.
No, they connect those
The light
lengths,
pieces.
and it does it make triangle.
What is it called?
Alright, so this ends our PLC meeting. We're discussing 6.8A and 6.8D and finding out ways that we can improve in those areas. Thank you guys.
Thank you so
Saying
much.
like the pieces
Thank you.
that, you know, like